welcome back AP Stats. We just finished our class, our live session with the Parkinson's simulation. So now we're ready to talk about p-values and what p-values mean, and I'll use that simulation to explain the concept of a p-value. And again, statisticians have trouble with the concept of a p-value. So this is really high-level stuff that you guys are learning and understanding. All right, p-value in statistics. The p-value is the probability of obtaining results as extreme as the observed results of a statistical hypothesis test, assuming that the null is correct. All right, so what that means is in our Joy simulation, right, our null was that Joy cannot smell Parkinson's. So we were saying if she's just guessing, she's going to get about 6 right. Well, she actually smelled all 12 and guessed all 12 correctly. Those results are extreme if our null is true. If it's true that Joy cannot smell, then how did she guess 12 out of 12 right? Those results are crazy. So what the p-value is the p-value is the probability of her getting all 12 right, but only guessing. Now that probability is very small, right? Because that's highly unlikely. So when you have a small p-value, your null, when you have a small p-value, your null hypothesis is probably not true. We calculated the p-value for Joy guessing 12 out of 12 correctly, and it was very small, right? So a small p-value in a statistical analysis means that the null hypothesis is not true. Probably not true. You can never say for certain. Okay, we'll get into how you calculate the p-value way later in the units and in the course. But for now, I just kind of want to get you to get used to the idea of analyzing a p-value and comparing it to a significance level. So significance level. When I say a small p-value, you're thinking, okay, how small is small? I mean, I could think one thing is small, and you could think another number is small, and they could be totally different numbers, right? So we need some sort of consistent test to be able to tell us if a p-value is small enough to say that the null hypothesis probably isn't true. And that consistent test is called the significance level or the alpha level. It's designated with this alpha signal right here. So it's stated in advance to determine how small the p-value must be in order to reject the null hypothesis. And when we say reject, we mean saying that the null is probably not true. All right, so if the significance value is not stated, then you can assume that it's 5% or 0.05. Every statistician or in their experiments can set their own significance level so that they can actually determine whether or not their results are statistically significant. Gosh, this is a bad class for me to teach because of my lisp. Statistically significant. All right, so what we're going to do is we're going to just look at p-values and significance levels and see which one's smaller or larger, because that's really all you're doing. When you calculate a p-value, you're going to compare it to your stated significance level. One of them is going to be bigger and one of them is going to be smaller, and that's how you base your conclusion. So right now, all we're going to do is look at these two numbers and compare them and fill out this column right here. So looking at this, which one is bigger? And if it's hard to tell with the decimals, you can kind of convert them to percents in your mind. This would be 2.3% and this would be 5%. So which one is smaller? The p-value. All right, looking at this one, tell me which one is smaller. If you convert this into a percent, this would be 14.8% and this would be 5%. So this would mean my significance level is smaller. All right, let's look at the next one. This is 3.19% and this is just 3%. So again, our significance level is smaller. All right, go ahead and do the next 3 on your own. Pause the video, do the next 3 on your own, and then come back and check your work. Okay, so for this one, I hope you said the p-value was smaller. See how there's 2 zeros behind the decimal, but only 1 0 behind the decimal here? With this one, I hope you said the alpha level was smaller. This is the same thing as approximately 7%, and this is 6%. All right, here, I hope again that you said the alpha level was smaller. This is 2%, and this is 2.01%. All right, now that we've figured out whether or not the p-value or the alpha level is the smaller number, let's see what that means. How to make a conclusion using the p-value and the significance level. So we've got two major conclusions in statistics. We can reject the null hypothesis, or we can fail to reject the null hypothesis. Now that wording is tricky, and it's kind of like, think about court cases, right? If you're on trial for something, the jury doesn't rule you guilty or innocent. The jury rules you guilty or not guilty because they can't say for sure that you're innocent. They can only say that you're either guilty or not guilty. It's the same type of concept in statistics. We can't say for certain whether or not the null is true. We're assuming the null is true for our test. The results of our test will either tell us that we can reject it or we can fail to reject it, but we can't come out and say it's true. I know that's annoying, but that is the way that statistics works. We either reject the null or fail to reject the null. So let's go ahead and say what that means. If we're rejecting the null hypothesis, that means we're saying the null is probably not true. All right, if we're saying the null is probably not true, then we're saying that the alternative is true. Remember, our null and our alternative are exact opposites, right? So if the null is probably not true, then the alternative is probably true. All right, if we fail to reject the null, what does that mean? That means the null is probably true. And the alternative is not true. And that makes sense when you're looking at these words, right? Rejecting the H null means we reject it. We reject it like an old boyfriend or girlfriend, right? We reject the H null, then that means that that null is probably not true and not worth our time. If we fail to reject, we're saying that the null is probably true. The results of our experiment were not significant enough to disprove the null. All right, so now that we've got what these mean, let's go back and make conclusions up here. So remember, if the p-value is smaller, we reject the null. If the p-value is larger, we fail to reject. All right, so here we said the p-value was smaller than the significance level. That means our results are statistically significant, and we are going to reject the null. The results were statistically significant. We're rejecting the null. Here, our p-value was larger than the significance level. If we have a larger p-value, we fail to reject. We're saying, the null is probably true. The results of our experiment were not significant. All right, I want you to go through and put the conclusion. Remember, you have two options. You're either rejecting the null or failing to reject the null. So go ahead, pause the video, try out the rest of these problems, and then come back and check your work. All right, so any of the problems where the alpha level was larger, that means we're failing to reject. We have one more scenario where the p-value is smaller, and there our results were statistically significant. So we are rejecting the null. We're saying the null is probably not true in this case right here. All right, I want you to go ahead and type out in the Edpuzzle section, what questions do you have right now? What is confusing to you? What do you want more practice on when we actually come back to the live session? All right, because different researchers use different levels of significance when they examine a question, a reader of published studies might have difficulty comparing results from two different tests. P-values are a solution to this problem because p-values are consistent, right? So one experimenter might say that 5% is their significance level, and another experimenter might say 1% is their significance level, right? So they might run the exact same study, but one of them will reject the null and the other will fail to reject. So that's why it's important to know what the significance levels of each study are and what the p-values what the p-values of the experiment are. And that way you can evaluate for yourself whether or not you think it's statistically significant. But again, this is just another way that some published studies might be interpreted differently, which just adds another layer to the confusingness of, studies and research. Okay, with this last page, we're going to put together everything that we've learned so far. So we're going to review writing hypotheses, and we're going to review analyzing the p-value and drawing a conclusion. All right, so example 4, a researcher claims that more than 23% of community members go to church regularly. In a recent survey, 126 out of 420 people stated they went to church regularly. The researcher performed a significance test and found the p-value to be around 0.003. Is there enough evidence at the significance level of 0.05 to support this claim? All right, so the first thing we need to do is write our hypotheses, right? So to do that, we need to know what variable we're using. Are we using p or mu? All right, looking at this, you should be seeing the percent and thinking that that's a clue, right? We're using p. P for proportion, right? Because the underlying data is asking whether the members of community go to church regularly or not. So that's a category. You're either in the category of going to church regularly, or you're in the category of not going to church regularly and sleeping in on Sundays. All right, so that now that we know it's a proportion, we can write out our hypotheses. Let me start off by just writing this term right here in a mathematical sentence. So P is more than 0.23. All right, so looking at this, I know that the null has to have an equal sign, a greater than or equal to, or a less than or equal to. And I know that the alternative has to have not equal to, greater than, or less than. These are the only signs that I can use with my null, and these are the only signs that I can use with my alternative. So looking at this statement I just made, it looks like I made the alternative hypothesis because it doesn't have an equal to sign underneath it, right? So let me go ahead and write out my alternative hypothesis. P is greater than 0.23. So now that I've got my alternative, I can write my null because I know it has to be opposite of that. So what is opposite of this alternative? It's that P is less than or equal to 0.23. All right, so when we actually run the significance test, which one are we assuming to be true? The null or the alternative? Which one do we assume to be true for our analysis? I hope you said the null. We assume this to be true. All right, we assume it to be true. We run all of our statistical analysis, which you'll find out how to do at a later date, and we get a p-value. So the p-value the p-value looks at the results based on their own study, right? So they did their study, and they created this p-value of 0.003. They said the significance level was 0.05. So looking at this, which one is smaller? This one has 2 zeros, and this only has 1. My p-value is smaller. If my p-value is smaller, what does that mean? Am I rejecting the null, or am I failing to reject the null? If you go back to our chart, if we have a smaller p-value, we reject the null. So what does this really mean? Let's go back to that chart right here. If we have a smaller p-value and we reject the null, that means the null is probably not true and the alternative is true. So let's go ahead and write that. What does our conclusion really mean? Our conclusion really means that more than 23% of people attend church regularly. Regularly. That's what our alternative is, right? If we reject the null, then we're saying that the alternative is true. So we're saying that more than 23% of people attend church regularly. That's what our results of our experiment or our survey proved, and it was statistically significant. So we can say that more than 23% of people attend church regularly. All right, let's look at example 5. Is there a difference in the IQs of art majors and science majors? A study was conducted, and the p-value was calculated using the sample data, and it gave us the p-value. All right, so is there a difference between the IQs of art majors and science majors? So if we're talking about IQs, we're talking about numbers, right? Your IQ is a number. So are we using p or mu? This is quantitative data, so which one are we using? I hope you said mu. All right, so, okay, so it's asking, is there a difference between the IQs of art majors and science majors? All right, so we've got two different samples, right? We've got a sample of IQs from art majors and a sample IQ from science majors. And we're basically saying, is there a difference between the two? So we've got two scenarios. We've got there is no difference, and there is a difference, right? So think about, what if the average IQs for the art majors were 150 and the average IQs for science majors were 150? When I subtract them, I get 0. 150 minus 150 is 0. There is no difference. If there were a difference when I subtracted them, I would not get 0, right? I would get my difference between the two. So these are the two scenarios I have. Either there is a difference or there's not a difference. So remember, back up here I told you that the null can only have one of these three mathematical symbols in it. It can only have an equal sign, a greater than or equal to, or a less than or equal to. So which of these two statements am I going to put in for the null? All right, I hope you said the one with the equal sign, because the null has to have the equal sign. That means I put the other one in for the alternative. Okay, for the statistical analysis that we ran, we assumed that one of these two hypotheses were true. Which one did we assume was true to run the statistical study? All right, hope you said the null. We're assuming that to be true for the study. All right, we ran the whole study, we did our statistics, we're very tired, we're ready to make a conclusion. We got our p-value. So our p-value was 0.051987. 0.051987. Wait, they didn't tell me a significance level, right? They did up here, but they don't down here. Does anyone remember what we're supposed to assume when we don't have one? Flip back to this page. If the significance level is not stated, we're going to assume it's 5% or 0.05. 0.05. All right, I want you to compare these two numbers and tell me which one's smaller. All right, looking at this is 5.19% and this is just 5%. So it looks like the significance level is smaller. If my significance level is smaller, that makes my p-value larger, right? If I have a larger p-value, I'm failing to reject. I fail to reject. Well, what does that really mean? If I'm failing to reject the null, it means the null is probably true. So, our null is probably true. There is no difference in the IQs of art majors and science majors. Our results were not statistically significant enough to reject the null, so we're still going to assume that it's probably true based on the results of our experiment and our p-value. All right, now I want you to go ahead and give example 6 a try on your own, and we'll go over it together in the next live session.